Steel making has been pivotal for society as we know it today. It all started with the discovery of iron ore, which is a rock containing iron mixed with other minerals. During this time, there developed different ways to process the ore. This typically involved high temperatures to melt and shape it into useful items. The early forms of iron were hard and brittle. After experimentation and innovation, cultures learned that additives like carbon made iron a superior material known as steel. This was a game changer for the applications of steel. Today, steel is one of the most used products around us. We use it for the majority of infrastructure around us, from railways, bridges, buildings, vehicles, and even military applications. Some of the techniques used to create steel were bloomeries, which used charcoal and iron ore in a chimney-like structure with heat. The Bessemer furnace, which was a similar process with more modernized equipment. The open hearth furnace, which was more of a pit with air injected from below. The basic oxygen furnace, a big vessel with the ore and oxygen injected continuously. An electric arc furnace that we use in present day. This technique uses mostly scrap which is recycled and melted using electricity. Over the years, we see the techniques used to make steel have shifted as newer, more innovative techniques emerge. Today, the two main types are basic oxygen processes and the electric arc furnace. But there is always the need to improve steelmaking. The evolution of steelmaking has been driven by the need for higher efficiency, improved quality, and sustainable practices, leading to continuous innovations in furnace technology, process control, alloy development, and manufacturing methods. The environmental aspect of these advancements must not be ignored. Steelmaking accounts for 9% of global greenhouse gas emissions. On top of this, 80 to 90% of the CO2 emissions from steelmaking come from the use of traditional blast furnaces. In traditional steelmaking, iron ore is reduced in a blast furnace. The blast furnace takes an iron ore and uses carbon-based reductants like coal and coke to produce pig iron. This reaction also produces a lot of CO2. Pig iron is then converted into crude steel in an electric arc furnace. Over 70% of the world's steel is produced using the blast furnace process. Hydrogen-based steelmaking is a disruptive technology in the world of steel. With hydrogen production techniques having become commercially viable, the steel industry can take advantage of advancements in hydrogen-based direct reduction of iron. It is also poised to create the largest environmental benefit to the industry as it replaces the notorious blast furnaces. The process is fundamentally different from traditional steelmaking. The blast furnace with coal and coke reductants is replaced by a direct reduction reactor, or shaft furnace in which iron ore is reduced using hydrogen gas as a reductant. The byproduct of this chemical reaction is water instead of CO2. Hydrogen-based steelmaking poses an immense environmental benefit but does not come without challenge. The environmental footprint increases if the process does not use green hydrogen, as in hydrogen made using renewable energy sources. The cost and availability of green hydrogen is currently an issue. Also, the required infrastructure changes to retrofit an existing steel mill with the technology are large. Hydrogen-based steel production is in its infancy, but companies are developing and implementing it. The first one to mention is Tata Steel. Formed in 2022 and located at IJmuiden, Netherlands, Tata Steel is the first large-scale application of hydrogen in the steelmaking industry. With a goal to produce steel with zero carbon emissions by 2045 and emissions of 35 to 40% less CO2 before 2030, Tata Steel started its Green Steel Hydrogen project at IJmuiden Works. Tata Steel aims to convert its steelmaking facilities from coal-based to hydrogen-based by using DRI technology, starting with the construction of a new hydrogen plant at IJmuiden Works. The new IJmuiden Works plant is expected to be operational by 2025 and produce up to 75,000 tons of hydrogen per year with zero carbon emissions upon completion. ArcelorMittal is developing a new, innovation project at our Hamburg site in Germany aimed at the first industrial-scale production and use of DRI, made with 100% hydrogen as the reductant, with an annual production of 100,000 tons of steel. The process of reducing iron ore with hydrogen will first be tested using gray hydrogen generated from gas separation. They aim to achieve the separation of H2 with a purity of more than 97% from the waste gas of the existing plant, using a process known as pressure swing adsorption. H2 Green Steel, located in Stockholm, Sweden has a target of producing 5 million tons of green steel annually in Boden by 2030 and reducing 0.3 billion tons of CO2 emissions by 2040, which is about 1% of total current annual man-made emissions. H2 Green Steel's technology uses green hydrogen produced through electrolysis using renewable energy sources. This hydrogen is then used as a reducing agent in the direct reduction process, where iron ore is converted into iron without using carbon-intensive coke. HYBRIT, Hydrogen Breakthrough Iron-Making Technology, is a collaborative project involving Swedish companies SSAB, LKAB, and Vattenfall. The project aims to revolutionize the steel industry by replacing coking coal, traditionally needed for iron ore-based steelmaking, with fossil-free hydrogen. HYBRIT's technology involves using hydrogen produced from renewable energy sources through electrolysis. Iron ore can be directly reduced using green hydrogen as a reducing agent. There are some other companies like voestalpine, JSW Steel, Helios, Electra, Carbon Re, Smart Steel, Gravidhigh who are also trying to make the best implementation of green hydrogen steel manufacturing. Overall, the whole range of green hydrogen steel production is already on the horizon, and if these things come together, the steel industry might begin putting the pedal to the metal sooner rather than later.